We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Hello everyone, myself Professor R.N.G from Electrical Engineering Department in R.N.G Patel Institute of Technology, Bardoli. Today we are going to discuss about a topic called Zener diode as voltage regulator. So let's not waste the time, let's go through this topic. Here we have seen the circuit diagram of Zener diode as a voltage regulator. One of the most important application of the Zener diode is as the voltage regulator. When load is connected to the rectifier, the DC load voltage changes with the change in the input AC voltage applied to the rectifier, or with the change in the load current, or both. This voltage across the load may be kept constant by making use of Zener diode. Zener diode with series resistor is connected in between the DC output terminals of the rectifier and the load, which is very much clearly shown in figure. Now let's talk about the parameter which is shown in figure. The Vi is called as input voltage, VO is called as output voltage, is nothing but Zener voltage, IL is called as load current, IZ is called as Zener current, ISC, that is nothing but total current, RAC is nothing but series resistor, RL is called as load resistor, and finally ISC is equal to IL plus IZ, that is total current is equal to load current plus Zener current. Clear? Now let's talk about the voltage drop in series resistor. The voltage drop in series resistor is, applied the KVL, Vi is equal to V0 plus ISC RAC. Now we have seen that ISC is nothing but IL plus IZ. So apply this equation IL plus IZ instead of ISC. So very next equation is Vi is equal to V0 plus IL plus IZ in bracket into RAC. Clear this? Now go through the working. Now let's talk about the working of Zener diode. Here I create one table to simplify the working and easy to understand. So let's go through this working. Now condition number 1. If the load current remains constant and if the input DC voltage increase, so the output voltage tries to increase, but the Zener diode takes more current. So current ISC increase, so voltage drop ISC RSC increase and output voltage does not increase and it remains constant. That is condition number 1. Now similarly, let's take condition number 2. If the load current remains constant and if input voltage decrease, the output voltage try to decrease, but this time Zener diode takes less current, so total current decrease and so series voltage drop decrease and output voltage V0 remains to the same value. Clear? Now let's try to understand its action when the input voltage remains constant and load current changes. Now we are going to remain constant input voltage and we are going to change load current. Now focus on condition number 3. If the load current increase with the constant input voltage, the total current try to increase. So the output voltage try to decrease, but it does not happen so because the Zener current decrease. So the total series current remains constant. So the voltage drop across the series resistor remains constant, with the result that the output voltage remains constant. Clear? Condition number 3. Now the last condition, condition number 4. Similarly, with the input voltage remains constant and the load current decrease, the Zener current increase to make series current constant. Zener current is increased. Why? Because Zener current increased to make series current constant. So the output voltage remains constant. Now I hope your all doubts have been cleared after watching this video lecture. Thank you very much.